Number 37 says microwave radiation has a wavelength of about a centimeter. Want to calculate the frequency and the energy of a single photon of this radiation. Calculate the energy of an Avogadro's number of photons. Avogadro's number is 1 mole. So here's what we want to do. We want to figure out the frequency and energy of a single photon. Ooh. Well, let's start with frequency. So again, frequency nu is equal to c over lambda. So c, let's just go ahead and jump right to it. I know c is 2.998 times 10 to the 8th meters per second divided by the wavelength, but wavelength's got to be in meters, and we've got it in centimeters. So we're looking at 1 centimeter. Let's make that the right number of sig figs. 1.0 centimeters times 100 centimeters in 1 meter. So we're looking at 0.01, or with sig figs it's going to be 1.0 times 10 to the minus 2 meters. So 1.0 times 10 to the negative 2 meters. These guys cancel out, seconds wind up on the bottom, and we get 2.998 times 10 to the 8th divided by 1.0 times 10 to the negative 2nd is going to be equal to 2.998, which it would actually be with sig figs, it's going to be 3.0. 3.0 times 10 to the 10th hertz, or over seconds, cycles per second, which is equal to 3.0 times 10 to the 10th hertz. So that's the frequency. The other thing we want to know is the energy of 1 photon. So energy, we know that E is equal to h nu. If I remember right, I believe this is per photon. So what we would do is take and multiply our frequency that we just figured out. This is nu. And we'd multiply that by h. Remember, h is Planck's constant, which is 6.626 times 10 to the negative 34th joule seconds. So all I would do is take this and go 6.626 times 10 to the minus 34th joule seconds times 3.0 times 10 to the 10th hertz, which is over seconds, or seconds to the minus 1, which means it would be in the denominator. These guys are going to cancel. I'm left with joules, and that is exactly, well, let's go ahead and do this. Drag this over here. It's going to be 6.626 times 10 to the minus 34th times 3.0 times 10 to the 10th, which is going to be 1.98, or 2.0 according to sig figs. 2.0 times 10 to the negative 24th joules. Double check that, I think I copied it right. Times 10 to the 23rd. Whoops. There's 10 to the 23rd joules. Now we want to know how much that is for an Avogadro's number of photons. Well, Avogadro's number is, we're familiar with that, that is 1 mole is Avogadro's number. So what we're going to do is we're going to multiply this 2.0 times 10 to the negative 23rd joules times 1 mole, because this is really joules per photon. Each photon has that much energy, so we're going to multiply that by 6.02 times 10 to the 23rd photons, 1 mole of photons. Photons cancel, and that's going to be equal to, let's go ahead and multiply that out. We got 2.0 times 10 to the negative 23rd times 6.02 times 10 to the 23rd. It's going to be about 1, and that's about 12. All right, so that would be 12 with 2 sig figs. 12 joules. All right, last but not least, 38.